Hello everyone, welcome to our new lecture, that is Introduction to Data Organization and Structure of a Database, that is from the lecture series of Business Data Processing and DBMS Fundamentals from Unit 3. Today we will explore how organizing data can make our digital lives easier, more efficient and more accurate. And myself, Dr. M.D. Ajij, Assistant Professor, Department of Computer Science and Technology. Here we will grab everything through very basic understanding with real life example. Imagine you have a collection of books at home. If these books are scattered all over the place, some on the floor, others under the bed, and few on the dining table, it would be hard to find a specific book when you need it. However, if you organize them neatly on the bookshelf, grouping similar type of books together, it becomes much easier to find the one you want. This simple idea of keeping things in order is what data organization is all about. Just like arranging books, organizing data helps us to find and use information more efficiently, whether it is on your computer, your phone, or in a big company's database. So, whether you are arranging your book collections or managing digital files, good data organization makes life simple and more efficient. Let's start by understanding what data is. Data is any kind of information that can be recorded and used for various purposes. This could be anything from your list of friends' phone numbers to your favorite movies, or even the records of patients in a hospital. Think of a data as a piece of information we collect and store to use whenever we need them. Now, why it is important to organize this data? There are three main reasons: efficiency, accuracy, and better decision making. So, first one is efficiency. What do you mean by efficiency? When data is organized, you can quickly find what you need without wasting time. Imagine trying to find a friend's phone number in a messy stack of a paper versus a neatly arranged contact book. That is efficiency. Second is accuracy. Organized data helps in maintaining accurate records. This is especially important in areas like finance, healthcare, and research. Accurate data means fewer errors and more reliable information. Third one is decision making. Having well organized data makes it easier to analyze and use for making informed decisions. For instance, a business can look at sales data to decide which products to focus on, or a hospital can use patient data to improve healthcare services. So, in summary, we can say data is all the information we collect and store, and organize this data helps us to be efficient, maintain accuracy, and make better decisions. So, by understanding and applying these principles, we can manage information more efficiently in our everyday life. And let's explore how data is organized. Data is organized in structures called database. Think of a database as a digital version of a neatly arranged bookshelf. Just like a tidy bookshelf, a database stores information in a systematic way, making it easy to access, manage, and update. Here are some key terms to understand. First one is database. What is database? Database is a collection of organized data. Then we look on to what is data organization. The process of arranging data in a structured way is called data organization. What do you mean the efficiency? Efficiency measures how quickly and easily you can access and use data. And what is accuracy? Accuracy is the correctness of the data. So, by organizing data effectively, we ensure that information is stored logically, making our digital lives easier and more efficient. Just like having a tidy bookshelf helps you find your favorite books in a seconds. As well, organized database helps in accessing important information quickly and accurately. Now imagine a library with thousands of books. If these books are scattered randomly, finding a specific one would be almost impossible. But when they are organized by genre, author or title, you can find what you need in no time. Database work the same way, but digitally they store data in tables with rows and columns, making it easy to manage and retrieve information. So in summary, what we can say, data organization involves arranging information systematically in database. This process enhances efficiency and accuracy, ensuring that data is easily accessible and reliable. By understanding and applying these concepts, we can better manage our digital information, just like keeping a tidy bookshelf at home. Now that we have understood why it is important to organize data, let's talk about how we actually do it by organizing database. Imagine your bookshelf again, but this time we will be more specific about how we place the books to keep everything in order. A database is like a digital bookshelf where data or information is stored in a very organized way. Each piece of data has its place, just like each book has its place on a shelf. This organization makes it easy to find, manage, and update information. Let's go through the steps to organize a database. Firstly, identify the purpose of your database. So the first, decide what the database will be used for. For example, if it is for a library, the database will need to store information about books, author, and borrowers. Next, break down the data into different type of information you need to store. Continuing with the library example, you might need sections of books, authors, and borrowers. Then we have to create tables, which are like shelves in your digital bookshelf. Each table stores a specific type of information. And here you can see the example book table containing the information about each book like title, author, publication year, and genre. Then author table containing information about each author like name, birth date, and nationality. Then borrower table that containing information about each person who borrows books like name, address, and contact information. Then define columns inside each table. Columns are like labels on the shelves showing what type of information is stored in each table. For example, in the book table, columns might include title, author, publication year, and genre. Add rows, each are like individual books on the shelf. Each row in table represent a single item of data. In the books table, each row would represent a different book. Then we need some relationship between tables. So set relationship between tables. This relationship helps to keep the data connected and organized. For example, the book table might have a column that links to the author table, showing which author wrote each book. Use a key to keep everything in order. Here primary keys are the unique identifier for each row in a table, like a unique ID number for each book in the books table. Foreign key are the columns that link one table to the another, like the author ID linking the books table to the authors table. And finally, once the structure is set up, you can start entering data into the database. With the database organized, you can easily search, sort, and retrieve the data you need. Let's walk through a simplified example of organizing a library database. This will help you understand how to manage information about books and borrowers efficiently. First, identify the purpose of the database. For our library example, the purpose is to manage information about books and borrowers. Next, break down the data into the different types of information you need to store. For our library, we will need data about books, authors, and borrowers. Now, create table for each type of data. In our library database, we will have three tables. One is book table, another is author table, and last one is the borrowers table. Now, our task is to define columns. So for define columns for each table, which specify what type of information each table will store. Suppose if you have a book table, then your book ID will be one column, another column will be title, and another column will be author ID. In this way, we can represent columns for each table. Then add rows to each table. Each row represents a single item of data. In the books table, each row would be a different book. In the author table, each row represents an author, and in the borrowers table, each row represents a borrower. Set relationship between tables to keep data connected. In our example, the books table will have an author ID that links to the author ID in the author table, showing with which author wrote each book. So use key to keep everything in order. Primary key are unique identifier for each row in a table, like book ID for each book, author ID for each author, and borrower ID for each borrower. And here foreign keys like author ID and the books table link to the author table to maintain the relationship between data. So by following these steps, you can create a well-organized database that stores information efficiently and make it easy to find what you need, just like neatly arranged bookshelf in a library. Remember, organizing your data not only makes it easier to manage, but also ensure that the information is accurate and accessible when you need it. Let's start another topic, that is structure of a database. So to understand how a database is organized, think of it like a well organized office with different sections and filing cabinets where all documents are stored. The structure of a database helps keep data in order and makes it easy to find and use. Let's break down step by step. First, we will talk about the tables. So, here a table is like a filing cabinet where related information is stored. Each table in a database stores data about a specific topic or entity. For example, in a library database, you might have a table for books, a table for author, and a table for a borrower. Another important component of a database, that is column. So columns are like labels on the drawer of the filing cabinet. Each column in a table represents a specific type of information that the table stores. For example, in the book table, columns could include the title, author, publication, years, etc. Rows are like individual files inside the drawers. Each row in a table represents a single record or item of data. For example, in the books table, each row represents a different book. A field is the intersection of column and row. It holds the actual data value. For example, in the book table, a field might contain the title of a book like Harry Potter. Let's look at a simplified example of a table structure for a library database. Here are the key components. One is book ID, next one is title, then author, then publication year, and last one is genre. Here book ID is a unique identifier for each book, acting as a primary key, and the title, the name of the book, the author, the name of the person who wrote the book, and the publication year, the year of the book was published, and genre, the category of type of each book. So each row in this table represents different book, and each field contains specific information about the book. For instance, Harry Potter could be the title of J.K. Rowling, the author, and 1997 the publication year, and the fantasy is the genre. The book ID is a unique number assigned to each book, ensuring that each record can be individually identified. So, in summary, the structure of a database includes tables, columns, rows, and fields. The organization helps keep data orderly, making it easy to find, manage, and use. By understanding these components, you can effectively organize and retrieve information, just like finding the right document in a well-organized office. So, remember, a well-structured database is essential for efficient data management and easy access to information. Now, let's talk about the keys in a database. So keys in a database are essential for organizing and connecting data within the table. We will focus on two types of keys. One is primary key and foreign key. So a primary key is the special column in a table that uniquely identifies each row. Think of it like a unique ID card for each record in the table. The key ensures that no two rows have the same primary key values, which help in keeping each record distinct and easily identifiable. In the book table, for instance, the book ID is the primary key. Each book has a unique book ID, making it easy to find and reference a specific book without confusion. On the other hand, a foreign key is a column that creates a link between two tables. It helps maintain the relationship between different sets of data. For example, in our library database, we might have a books table and a author table. The foreign key allows us to connect these two tables. Let's say we have an author table with author ID as the primary key. In the book table, the author column can be a foreign key that link to the author ID and the author table. This connection helps us know which author wrote each book. So what is the importance of the keys? Using the primary and foreign keys, we can effectively organize and connect the data across different tables. The structure ensures the data integrity and makes it easy to retrieve and manage related information. For instance, by using the book ID as a primary key and the author as a foreign key, we can easily find all the books written by a specific author. This setup not only helps in maintaining a well-organized database but also make data retrieval more efficient. So in summary, primary key uniquely identify each record in a table, ensuring data integrity. Foreign keys links different tables, helping maintain relationship between datasets. So by understanding and using these keys, we can keep our database organized and efficient, just like a well-connected library system. Remember, keys are the fundamental to managing and connecting your data, making it accessible and easy to use. Now let's move on to the another topic, that is relationship between tables. Understanding relationship between tables in database is key to organizing data efficiently. Let's explore three common type of relationship: one-to-one, one-to-many, and many-to-many. In one-to-one relationship, each row in one table is linked to one row in another table. Think of it like a student and their unique student ID card in a school database. So each student has one unique ID card and each ID card belongs to one specific student. In one-to-many relationship, one row in one table is linked to multiple rows in another table. For example, consider an author and their book. One author can write many books. So in library database, one author in the author table can be linked to many books in the book table. And in many-to-many relationship, multiple rows in one table are linked to multiple rows in another table. A good example is students and courses in a school database. So each student can enroll in many courses and each courses can have many students. So let's look at a specific example by using two tables, that is author and books. In this case, the author ID in the book table is foreign key that link to the author ID in the author table. This relationship helps us know which author wrote each book without repeating the author's information in the book table. So by structuring database with this relationship, we can efficiently store, retrieve and manage data. The clear organization of tables, columns, rows, fields and keys ensure that the database remain tidy and easy to use, just like well-organized office. So in summary, understanding relationship between tables, whether one-to-one, one-to-many or many-to-many, helps us to create efficient and organized database. By linking related data through keys and relationship, we can maintain the tidy and easily accessible system, much like well-structured office. Remember, organizing data through these relationships ensure that your database is both effective and user-friendly. And at the end of this lecture, we conclude that organizing data into database involves creating tables, defining columns and rows, setting up keys and relationships. This structured approach enhances efficiency, accuracy, and decision making. By understanding this principle, we can manage information effectively, much like keeping a tidy bookshelf at home. Thank you for watching.